Suppose if it is equal to 1.9, 1.99, 1.999, so that means the value of x will approaches to a value which is nearly equal to 2. Limit extends to a of f of x is equal to L, means the value of f of x is nearly equal to L when x is nearly equal to a. Product. Limit extends to a of f of x into g of x can be written as limit extends to a of f of x into limit extends to a of g of x. Hello dear students, welcome to this session of Mathematical Foundation class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence. Today in this session I am going to discuss regarding very important concept, that is the second part of unit 3, that is limits and derivatives. Very important concept. You may expect one full question from this concept. Now let us know regarding the definition of a limit. Now what is the meaning of x tends to a? This is nothing but x tends to a. How to read? The meaning of x tends to a. This arrow mark indicates tends to. X tends to a. That means let x be a variable, let x is any variable and a is any constant. If x is a variable and a is a constant, since x is a variable, we can change its value. It can be changed so that its value comes nearer and nearer to a. The value of x will approaches to a value nearer and nearer to a. It is approaches to a value which is nearly equal to a is denoted as x tends to a. That is, we say that x approaches to a and it is denoted as x tends to a. This is x tends to a means x approaches to a value which is nearly equal to a. For example, let us consider x approaches, suppose if it is equal to 1.9, 1.99, 1.999. So that means the value of x will approaches to a value which is nearly equal to 2. So that is the meaning here. So that means x is a variable and a be a constant. Since x is a variable, we can change its value. It can be changed so that its value comes nearer and nearer to a. That is like this. We can say that x approaches to a and it is denoted as x tends to a. X approaches to a. That means the value of x is nearly equal to a. That is denoted as x tends to a, approaches to a. Now, by knowing this, let us know regarding the limit of a function. What is the definition for limit of a function? Let f of x be a function defined on an interval containing x is equal to a except possible at x is equal to a. Then we can say that limit extends to a of f of x is equal to L. So, the value of limit f of x is equal to L when x is nearly equal to a. So, in general, as x tends to a, f of x will tends to L, then L is called the limit of the function f of x, which is symbolically represented as limit extends to a of f of x is equal to L. That means the value of f of x is nearly equal to L when x is nearly equal to a. So, limit extends to a of f of x is equal to L means the value of f of x is nearly equal to L when x is nearly equal to a. That is the meaning of the statement limit extends to a of f of x is equal to L. Now, let us come to the next concept, limit of polynomial and rational functions. Suppose if f of x and g of x are any two functions, f of x and g of x are any two functions, then we have let f of x and g of x be two functions such that both limit extends to f of x and limit extends to a of g of x exist. If the limits for both the function f of x and g of x at x is equal to a exist, then we have limit extends to a of f of x plus g of x is equal to term by term limit. Just apply the limit for first term plus second term. Limit extends to a of f of x plus limit extends to a of g of x. That is, just apply the limits for each and every term. Now, that is limit extends to a of f of x plus g of x can be written as limit extends to a of f of x plus limit extends to a of g of x. Similarly, if it is minus, that means limit extends to a of f of x minus g of x can be written as limit extends to a of f of x minus limit extends to a of g of x. So in general we can write like this totally, that is limit extends to a of f of x plus or minus g of x can be written as term by term limit application. Just apply the limits for term by term. So just apply the limit for first term f of x, limit extends to a of f of x. If it is plus, put plus or minus same limit extends to a of g of x. That's all. Now let us know regarding the quotient and constant. Now suppose limit extends to a of f of x into g of x, product. Limit extends to a of f of x into g of x can be written as limit extends to a of f of x into limit extends to a of g of x. Suppose if it is quotient, limit extends to a of f of x by g of x, just apply the limit for both numerator and denominator. Limit extends to a of f of x divided by limit extends to a of g of x. Suppose if it is limit extends to a of lambda into f of x, where lambda is a constant. So just keep lambda constant out and apply the limit for the function, limit extends to f of x. So product, if it is a product, just apply the limit for both the function, limit extends to f of x into g of x is equal to limit extends to f of x and limit into limit extends to of g of x, and limit extends to f of x by g of x is equal to limit extends to f of x by limit extends to of g of x. Similarly, limit extends to f lambda into f of x means lambda is kept constant and apply the limit for the function. So we can also write like this, limit extends to a of a constant into function, where k is a constant. Constant into function is there means you can remove the constant out and apply the limit for the function, limit extends to a of f of x. That's it. So this is how we are going to apply the limits for algebraic functions. And these are some important basic rules of limits. But let me explain with an example. Evaluate the following limits. Now limit extends to 3 of x plus 3. Just very simple. Put x is equal to 3 here. If you put x is equal to 3, then this becomes 3 plus 3. 3 plus 3 is equal to 6. So the value of this limit is, that means, so here you can observe limit extends to a of f of x is equal to L means the value of limit is equal to 6 when x is nearly equal to 3. So here f of x is x plus 3. When x tends to a means x is equal to a means x is equal to 3. The value of the limit L is equal to 6. So this is the meaning of the limit of a function. Now limit of this. Let us take another example. Limit r tends to 1 of pi into r square. Now just put r is equal to 1, then this becomes pi into, what is r? R is 1 square. Pi into 1, that's equal to pi. The value of limit is equal to pi. That's it. The value of this limit is 6 here. The value of limit here is pi. That's it. So these are very simple problem for 2 marks. Move on to the next problem. Now limit extends to 1 of x cube minus x square plus 1. On the other hand, limit extends to 4 of 4x plus 3 divided by x minus 2. Now let us come to this third one. These are important type of problems. You may expect this type of questions for 2 marks. Now put x is equal to 1 here. If you put x is equal to 1, then this becomes 1 cube minus 1 square plus 1. What is 1 cube? 1 into 1 into 1 is 1. 1 square is 1 plus 1 minus 1 plus 1 gets cancelled. This is equal to 1. So the value of limit is equal to 1. Now here limit extends to 4 of 4x plus 3 divided by x minus 2. Now put x is equal to 4, then this becomes 4 into 4 plus 3 divided by 4 minus 2. 4 4s are 16 plus 3 divided by 2. What is 16 plus 3? This is 19 by 2. The value of limit is equal to 19 by 2. Very simple. Put x is equal to 4, then 4 into 4. 4 4s are 16 plus 3, 19 divided by 4 minus 2. That's equal to 2. 19 by 2 is the simplified answer, the value of limit. Now, move on to the next problem. Evaluate, this can be written as evaluate. Limit extends to 2 of x cube plus 4x square plus 4x divided by x square plus 4. Very simple problem, very important for 5 marks. Put x is equal to 2. If you put x is equal to 2, 2 cube plus 4 into 2 square plus 4 into 2 divided by, in the denominator, 2 square plus 4. So 2 cube, 2 2s are 4, 4 2s are 8, plus 4 into 2 square is 4, plus 4 into 2 is 8, divided by 2 square, 2 2s are 4. So this can be written as 8 plus 4 4s are 16 plus 8 divided by 4 plus 4 is 8. So 16, 8 plus 8, 16, 16 plus 16, 32 divided by 8. So what is this equal to? 4, 8 4s are 32. That's equal to 4. That's all. So the simplified answer for this is 4. That's it. Just here, put x is equal to 2. If you put x is equal to 2, 2 cube is 8, 4 into 2 square is 4, 4 4s are 16, 4 into 2 is 8, 8 plus 4 4s are 16 plus 8, 8 plus 16 plus 8 divided by 2 square is 4 plus 4, 8. 32 by 8 is equal to 4 is the simplified answer. Now move on to the next problem. Evaluate limit x tends to minus 1 of x to the power of 10 plus x power 5 plus 1 divided by x minus 1. Here also, now put x is equal to minus 1. If you put x is equal to minus 1, this becomes minus 1 whole to the power of 10 plus minus 1 whole raised to 5 minus 1 divided by minus 1 minus 1. If you multiply minus 1 10 times, what you will get? Minus 1 into minus 1 into minus 1 up to 10 times. If you multiply minus 1 10 times, you will get plus 1 itself. If you multiply minus 1 5 times, so minus 1 to the power of 5 is nothing but minus 1 into minus 1 into minus 1 into minus 1 into minus. 1 1 1 1 is 1. 1 into 1 into 1 5 times is 1. Minus into minus plus, plus into minus minus, again minus into minus it is plus, plus into minus it is minus. So if you multiply minus 1 5 times, you will get a negative. If you multiply 10 times, you will get positive, depending upon the odd and even. So powers. Now this is plus 1, this becomes minus 1 divided by minus 1 minus 1. Now this minus 1 plus 1 gets cancelled, minus 1 divided by minus 2, this is equal to 1 by 2. So the simplified answer is minus gets cancelled, you will get 1 by 2 as the answer. Now move on to the next problem. Evaluate limit x tends to 2 of 3x square minus x minus 10 divided by x square minus 4. Now this can be written as put x is equal to 2. So what happens if you put x is equal to 2? Then this becomes 3 into 2 square minus 2 minus 10 divided by 2 square minus 4. 3 into 2 square is 4 minus 2 minus 10 divided by 2 square is 4 minus 4. 3 4s are 12. This is 3 4s are 12 minus 2 minus 10 divided by 0. So 12 minus 2 is plus 10. So this can also be written as 12. Minus 2 minus 10 is minus 12 by 0. 0 by 0 form is obtained. Now by putting x is equal to 2, 0 by 0 form is obtained, which is an indeterminate form. This is an indeterminate form. Now let us factorize the numerator and denominator. The numerator can be written as 3x square minus x minus 10. Factorize this by cross multiplying. 3x into x, this is 5 into 2. So you can put plus and minus here. So what happens? 3 into 2 is minus 6x. Again plus 5 into x is 5x. If you subtract, you will get minus x, the middle term. So plus into minus minus. 5 2s are 10, 3x into x is x square. The factors are 3x plus 5 into x minus 2 are the factors. Now substitute here. So this limit becomes limit x tends to 2 of, in the numerator we can put 3x plus 5 into x minus 2 divided by, the denominator is of the form x square minus 4 can be written as x square minus 2 square. This is nothing but x plus 2 into x minus 2. A square minus b square. A square minus b square is equal to a square minus b square is a plus b into a minus b. So using that we can write x minus 2 into x plus 2. So here this x minus 2 gets cancelled. What is left? Limit x tends to 2. In the numerator, we have 3x plus 5 divided by, in the denominator, x plus 2. Now, put x is equal to 2. If you put x is equal to 2, then this becomes 3 into 2 plus 5 divided by 2 plus 2. 3 into 2 is 6. 6 plus 5 divided by 4. That's equal to 11 by 4 is the simplified answer. So, the simplified answer in this case is 11 by 4. That's it. Hope you followed. Okay. So, just factorize the numerator and denominator. So, denominator is a plus b into a minus b, whereas this is a quadratic equation. Again, 3x squared minus x minus 10. Factorize, just you will get the factors as 3x plus 5 into x minus 2. X minus 2 gets cancelled. We will get so 3x plus 5 divided by x plus 2, put x is equal to 2. The simplified answer is 11 by 4. Now move on to the next problem. Evaluate limit x tends to 2 of x cube minus 2x square divided by x square minus 5x plus 6. Now put x is equal to 2. If you put x is equal to 2, put x is equal to 2, what happens? This is 2 cube minus 2 into 2 square divided by 2 square minus 5 into 2 plus 6. 2 cube is 8. 2 square is 4 2s are 8 divided by 2 square is 4, 5 2s are 10 plus 6. So, this is 8 minus 8 is 0, 4 plus 6 is 10 minus 10 is equal to 0. Again, this is 0 by 0, which is an indeterminate form. Now, factorize this. So, here we can write this given equation can be written as limit x tends to 2 of, in the numerator, you can take x square common factor. What we will have? X minus 2. X square into x is x cube minus 2x square. Now factorize the denominator, that is x square minus 5x plus 6, a quadratic equation as usual, 3 into 2 x into x. So this is minus and minus, minus into minus plus, minus 3 into minus 2 is plus 6. So if you simplify, minus 3x minus 2x is minus 5x. The factors are x minus 2 into x minus 3 are now substitute here. So, in the denominator, we can write the factors as x minus 2 into x minus 3. So, here x minus 2 gets cancelled. What is left? Limit x tends to 2 of x square divided by x minus 3. Now, put x is equal to 2. If put x is equal to 2, what you will get? 2 square divided by 2 minus 3. 2 square is 4 divided by 2 minus 3 is minus 1. That's equal to minus 4 is the simplified answer. That's it. Okay. Very simple. See here. So, by putting x is equal to 2, we will get 0 by 0, which is an indeterminate form. So, this can be simplified by factorizing. In the numerator, you can take x square common factor. So, x square into x minus 2, in the denominator, x square minus 5x plus 6 can be written as, by factorizing, the factors we are going to get is x minus 2 into x minus 3. Then this is minus 2 gets cancelled, x minus 2, x square divided by x minus 3, put x is equal to 2, 2 square is 4 by minus 1 is minus 4 is a simplified answer. Now move on to the next problem. Limit x tends to 1 of ax square plus bx plus c divided by cx square minus bx plus a. Now, where a plus b plus c is not equal to 0. Very simple. Put x is equal to 1, that's all. If you put x is equal to 1, a into 1 square plus b into 1 plus c divided by, in the denominator, c into 1 square minus b into 1 plus a constant as it is. A into 1 square is 1 into a is a, 1 into b is b plus c divided by c into 1 square is 1, c into 1 is c minus b plus a. So, a plus b plus c divided by c minus b plus c is the answer, or if you want, you can also write like this, a plus b plus c divided by, in the denominator, you can write a minus b plus c. This is the simplified answer. Very simple. Put x is equal to 1, you will get a plus b plus c divided by a minus b plus c. Now, move to the next problem. What is the problem? Evaluate limit x tends to 0 of ax plus b divided by cx plus 1. Evaluate. Now, here also put x is equal to, just put x is equal to 0, that's all. If you put x is equal to 0, a into 0 plus b divided by c into 0 plus 1. A into 0 is 0 plus b divided by c into 0 is 0 plus 1. 0 plus b is b, 0 plus 1 is 1, b by 1 is equal to b. The simplified answer is b, that's all. See, if you put x is equal to 0, this becomes 0, b by 1, that's nothing but b, that's it. This is 2 marks question, very simple for 2 marks. Right. So this is how we are going to solve the problems in limits. This is how we are going to evaluate the limits of algebraic functions, right? Hope you followed. That's all regarding today's session. Let us meet with a different concept in the next session. Thank you very much.